Welcome to the 2004 AP Calc AB FRQ number 2. In this problem, we are given a region here bounded by f of x, which is 2x times 1 minus x, and g of x, which is 3 times x minus 1 times root x, from 0 to 1, which is where they intersect. So in A, you're asked to find the area of the shaded region enclosed by the graphs of f and g. So you can start by setting up this general area integral, which is the integral from a to b, of big R of x minus little r of x, big R being the upper function and little r being the lower function, essentially meaning that one is above the other, as in this case. So we can plug in the limits and the functions now. So a becomes 0 and b becomes 1. Big R of x becomes 2x times 1 minus x because f of x is above. And little r of x becomes 3 times x minus 1 root x because g of x is below. A nice trick that you can use for this problem was supplied to you by College Board. They defined the functions for you, so you can save some time by just writing the integral from 0 to 1 of f of x minus g of x dx equal, and then you plug that into your calculator and it spits out 1.133. So let's move on to B. In B, you were asked to find the volume of a solid generated when the shaded region enclosed by the graphs of f and g is revolved around the horizontal line y equals 2. So, start by drawing a hypothetical y equals 2. So now, f of x is not the above function. So, let's flip it over. Now, you can tell easily that g of x is the upper function because it is a larger distance to y equals 2 than f of x is. So, you can draw a general volume integral, which is pi times the integral of a to b of big R of x minus number being the number in the line, so like y equals 2 squared, minus little r of x minus number squared dx again. So let's plug it in again. You get pi times integral 0 to 1 g of x minus 2 squared, again using that nice trick that College Board gave you of the defined function, minus f of x minus 2 squared dx. You plug that into your calculator and you get 16.179. Let's move on to C now. So C is asking you to find an integral function that will give a volume of 15. So it asks you for this function here, h of x equals kx times 1 minus x. So we know that k is also greater than 0, so it has to be above this line. So we know that the volume of f of x g of x is a little bit over 16. So h of x has to be a little bit below f of x. So let's start by looking at the volume integral, which is v equals a b s squared for the cross-sectional volume when you're using squares as the shape. So we need to find the side of the square, which would be this value right here. So we need to find what h of x, which is kx times x minus 1, minus 3 times x minus 1 root x, or g of x, again, right here, h of x minus g of x. You square that here for the volume function, plugging in 0 and 1 for the limits again. Make sure the squared dx. And then you just set it equal to 15 because that's what they're asking for, because this is essentially volume equals 15 and then the way to find the volume. So let's go back and look at the grading of these problems. So in problem A, you are getting a point for the integral and the answer. So for the integral portion, you need to make sure you have d of x and the limits right, along with, of course, the functions inside. And then for the answer, you need to either make sure you truncate it at 3 decimal places, or if necessary, round up. For B, you're getting 2 points for the integrand, so you need, which includes pi, the limits, dx, and whatever inside. If you miss one of those points, you'll take a point off. And then for the answer, you're also getting the points for truncating or rounding to the correct decimal. Make sure when you're calculating your value, you don't forget to multiply this part by pi, or else you'll get the wrong answer. In C, you're again getting 2 points for the integrand, which would be here, and then you getting another point for setting it equal to 15 down here. And again, through this whole process, make sure you have the d of x correct, because that will nick you a point off. So if you're looking for some extra practice, you can go to these problems: 2003 number 1, 2005 number 1, 2006 number 1, 2007 number 1, 2008 number 1, 09 number 4, 2010 number 4, and 2013 number 15. These problems are all similar. They're all in the form of A, find area, B, find a revolved volume, and C, just like in this problem, find volume cross-sectionally, because those are the most common ways to use this type of problem, and it is a very diverse set. Number 8 is a little more tricky. It involves using a multiplied function and depth, but it is very manageable, and I know that everyone in our class can do it. Thank you for taking the time to watch this video. I'm Jordan.